capillaries and small blood vessels. It's an amazingly elegant motion picture considering when it was made in the late 1919 and 1920. Most of the images are from capillaries and blood vessels in the frog, and for that reason the red blood cells are elliptical in shape and are nucleated, as you can see in this scene. The next sequence is also of the frog lung. This is a picture more or less what Malpighi would have seen in the 1600s when he looked at it with a magnifying glass. It's also an example of sheet flow as has been described previously. This a little higher magnification illustrates the deformation of the erythrocytes as they pass through this extensive capillary network in the lung of the frog. It should be noted, however, that frog erythrocytes, because they're enucleated, are not as plastic and flexible as are those of mammals which have nuclei. This shows some stimulation of the blood vessel, small vessel in the nictitating membrane, and you can see all the changes in flow as the diameter of the vessel changes during stimulation. These, of course, are mammalian red blood cells, which lack a nucleus and are biconcave discs. This film was filmed by the Clarks at the University of Pennsylvania in the 1930s and illustrates the responses of the blood vessels regenerated in the ear of the rabbit in the rabbit ear chamber to cold. The decrease in temperature was provided by going outside and taking some snow and packing it around the ear of the rabbit. And as the temperature changed, as the snow melted, they looked at the reestablishment of blood circulation as indicated by the subtitles. Most of these early films had graphic as well as textual material included in them, and as you will see, telling you what is coming in the subsequent scenes. And that's the case with this one. Now as the temperature approaches 97 degrees, or body temperature, the flow is quite rapid and back to essentially normal conditions. With the removal of heat, an inflammatory reaction begins to take place, and white blood cells begin to stick to the endothelium of these vessels. This may well have been some of the first recordings of a microvascular inflammatory response. And with time, increasingly larger numbers of white blood cells were sticking to the endothelium. The following scene shows examples of vasomotion. What also can be seen here is the evidence of streamlined flow in the larger arterial in particular, with the light area, and the peripheral plasma layer you can see at the edges. But it's a very good example of vasomotion in these vessels.